Hello everyone, myself Sneha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you the topic LTI system characterized by impulse response from the subject of signals and system from the second unit, which one is behavior of continuous time and discrete time LTI system, means linear time invariant system. Now the next topic is step response of an LTI system. So how will deriving the step response of LTI system? If we will applying unit step signal as the input signal to any system, and if we will deriving the output, then it will consider as the step response of that particular LTI system. So if you want to derive the step response of this LTI system, so for that we will take in the convolution output y of n equals to x of n convolved with h of n, right? So we will taking y of n equals to x of n convolved with h of n by using the commutative property. We will write in y of n equals to h of n convolved with x of n. Now if we will applying the equation to this term, then the equation will be like this: summation k equals to minus infinite to infinite h of k x of n minus k. It means one signal as it is, the second signal is folded, shifted, then we have taken overlapping by taking multiplication and at last summation. Right, so this one is the equation of convolution output. Now as I have told you that if you want to take the step response, so for that we have to take the input signal as unit step signal. So for that we have to take the input signal x as a unit step signal. It means we are taking x of n equals to u of n. So instead of this x of n minus k, we have to take u of n minus k. So it will give you the output, which is step response, right? So we are taking input signal x of n as the u of n. So in this term we have to use x of n minus k, right? So for that we will finding the value of x of n minus k. So in the above equation, instead of n, we have taken n minus k term. So the term will be x of n minus k equals to u of n minus k, right? Now if we are using this term over here, then the output y of n equals to summation k equals to minus infinite to infinite h of k x of n minus k. Instead of x, we will take in u of n minus k. Now using u of n, what is u of n? U of n equals to 1 for the range of n for 0 to infinite, right? So by using this term, first of all we will folding the signal, then we will shifting the signal toward the right side. So after that it will give you the output as a 1 for the range of k is in less than or equals to n. So the value of u of n minus k equals to 1 for k less than or equals to n. So if we are using this term in the above equation, then the term y of n equals to summation k equals to minus infinite to n h of k into 1, because we have taken the value of k which is less than n. It means from minus infinite to n, right? So the range will convert it like this: minus infinite to n, h of k will be as it is. Instead of u of n minus k, its value will be 1. So h of k into 1 will gives you the term as h of k. So this term will be representing as step response. So by using this equation, we can find out the step response of discrete time signal. Now if you want to find out for the continuous time signal, then the equation will change like this: instead of the summation, we will taking the integration, and instead of this k, we will use dummy variable as tau, right? So the term will be s of t equals to integration minus infinite to t h of tau dθ. So by using these two equations, we can find out the step response of discrete time signal and the continuous time signal. So for this, we will solve some example. The first example is evaluate the step response of the LTI system represented by the following impulse responses. The first impulse response is h of t equals to e raised to minus mod of t. Second one is h of n equals to minus 1 raised to n u of n plus 2 minus u of n minus. So to start solving this example, first of all we are starting with the first term, which one is h of t, which is the continuous time signal, right? So for the continuous time signal, the step response s of t equals to integration minus infinite to t h of tau deta. So to find the step response, we require the term as h of tau. So instead of this t, we have to use tau. So in this equation, instead of t, we will be taking the term as tau. So the term will be h of tau equals to e raised to minus mod of tau. Now we will put in this value in this equation. So the step response s of t equals to integration minus infinite to t e raised to minus mod of tau deta. Now as you know that the value of mod of tau will be minus tau for the range of negative terms like minus infinite to 0, and for the positive range its value will be tau, right? So we will dividing this whole range into part negative range plus positive range. So the term will be like this, minus infinite to 0, this one is negative range. For that the term value of mod tau is equals to minus tau. So minus minus plus tau. So the term will becomes like this, e raised to tau deta. And for the positive range, it means from 0 to infinite, its value will be tau. So tau into minus means minus tau, right? So the term will be e raised to minus tau deta. Now we have to solve this two terms. So the next step is s of t equals to e raised to tau. If we are integrating e raised to tau, then its integration will be e raised to tau. And if we are integrating e raised to minus tau, then its value will be e raised to minus tau divided by minus 1, right? So we have used this to integration. And the range will be, for the first term, its range is minus infinite to 0. And for the second term, its range will be 0 to 3. Now if we will apply this two ranges over here, then the term will be e raised to 0 minus e raised to minus infinite plus for the second term its value will be e raised to minus t minus e raised to 0 upon minus 1. It means higher range minus lower range. Now if we are solving this term, then as you know that e raised to 0 means 1 and e raised to minus infinite means 0. So the term will be like this, s of t equals to 1 minus 0 plus e raised to minus t minus 1 divided by minus 1. So if we simplify this, minus minus this one is plus and this minus goes over here. So it will consider as minus e raised to minus t. This one is 1 and this one is 1. 1 plus 1 means its value will be 2. So final answer of s of t equals to 2 minus e raised to minus t. So this way we can find out the step response of any term. So we have find for the continuous time signal. Now we are solving for the second term, which is discrete time signal. So for this we will taking the second term as h of n equals to minus 1 raised to n u of n plus 2 minus u of n minus 3. So for this step response s of n equals to summation k equals to minus infinite to n h of k, right? So for this, first of all we have to find out the value of h of k. So in this equation, instead of n, we have to take k to find out h of k. So first of all, we will finding the value of h of k, which is minus 1 raised to k, u of k plus 2 minus u of k minus 3. In this equation, we have taken k instead of this n, right? So this term will be there. Now we are using this equation over here. So what will be the term? S of n equals to summation k equals to minus infinite to n minus 1 raised to k, u of k plus 2 minus u of k minus 3. So first of all, we will simplify this term. This term is unit step signal. So if we simplify this term, then we can solve this example, right? So for this, first of all, we will find in u of k plus 2 minus u of k minus 3. So first of all, we will draw any u of k. What is u of k? U of k means unit step signal and its value will be 1 for k equals to 0 to infinite. So we have drawn like this, for k equals to 0 to infinite, its value will be 1. Now we have to find out the value of u of k plus 2. K plus 2 means this signal will shift toward the minus 2 side. So the term will be from minus 2 to infinite, its value will be 1. Now if we are finding the value of u of k minus 3, then its value will be k minus 3 means it will shift from the 3, right? So it will starting from 3 to infinite, its value will be 1. Now if we are subtracting this two terms, this term minus this term, it means 1 minus 0 means 1 and 1 minus 1 means 0. So for the range of minus 2 to 2 only, its value will be 1. Otherwise, its value will becomes equals to 0. If we simplify this, right? So for this range of the summation will become now like this, minus 2 to 2. So S of n equals to this equation. In this we will changing the range of, it will be minus k equals to minus 2 to 2, minus 1 raised to k, and this term will become equals to 1. So 1 into minus 1 raised to k equals to minus 1 raised to k. Now if we are simplifying this term, then the term will be any term raised to n, and if we are applying its summation, then the term will be a raised to lower range minus a raised to upper range plus 1 divided by 1 minus a, right? And here the value of a equals to minus 1 and lower range equals to minus 2 and upper range equals to 2. So if we apply this over here, then the term will be like this. Now if we are simplifying this, then its value will be 1. In this we have taken the range of n which is greater than 2. Now if we are taking the value of n which is less than 2, then what will be the term? So S of n equals to this term, right? In this, if we are taking the value of n in between minus 2 to 2, then the overlapping will in between only minus 2 to n. So the value of summation k equals to minus 2 to n, because the value of n will be less than 2, right? It means up to n only there will be overlapping. So the range of it will be summation k equals to minus 2 to n minus 1 raised to k. Now if we are simplifying this term, a raised to lower range which is minus 2 minus a raised to upper range plus 1 means n plus 1 upon 1 minus a. And instead of a we have to take minus 1. Now if we are simplifying this term, then the answer of S of n equals to 1 plus minus 1 raised to n divided by 2. So this way we can solve any example to find out its step response. Now the second example is the impulse response of the system is phi into e raised to minus 10t for t greater than 0. Now for this you have to find out its step response. So if you want to solve this example, first of all, what is step response? As this equation is in the form of t, then it is considered as continuous time signal, right? So for that we have to take the integration. Now if we are taking the integration, so step response S of t equals to integration minus infinite to t h of tau dt. So this value is given to you as h of t. Instead of t we have to take tau to find out the value of h of tau. So what is the value of h of t? H of t equals to phi into e raised to minus 10, right? So value of h of tau equals to phi into e raised to minus 10 tau. Instead of this t, we have taken tau to find out h of tau. Now this h of tau will putting the value over here. So the step response S of t equals to integration minus infinite to t phi into e raised to minus 10 tau beta. As we have taken t greater than 0, so this range will convert from 0 to t. So the value will be 0, integration 0 to t, phi into e raised to minus 10 tau beta. Now if we are solving this term, then the value of S of t equals to phi is constant, so it will be outside of this integration. So phi into 0 to t, e raised to minus 10 tau beta. Now in this, if we are integrating e raised to minus 10 tau, so its integration is e raised to minus 10 tau divided by minus 10. Now if we are putting the higher value minus lower value, so the term will be phi into e raised to minus 10t minus e raised to 0 divided by minus 10. Now as e raised to 0 equals to 1, so we will simplify this term as phi divided by 10 is 0.5. So the final answer is S of t equals to 0.5 minus 0.5 into e raised to minus 10. So this way we can solve any example of the step response for the continuous time and discrete time signal. Thank you so much.